Okay, so in this lesson, this is going to be on chapter 2.6 in the OpenStax textbook on solving compound inequalities. So in the last video, we talked about solving linear inequalities where we had one inequality. In compound inequalities, we're going to have multiple inequalities that we're working with at the same time. So the definition of what a compound inequality is, according to the book, is it's two or more inequalities that are connected by either an and or an or. So there's two different kinds of compound inequalities, right? We can have the and type, and we can have the or type, right? So for example, we might say x is greater than 3 and x is less than 5, right? Or we could say x is greater than 3 or x is less than 5. Okay? And those mean two different things, and I'll show you kind of what they mean. We'll go over these individually. So first we're going to talk about the and type of inequalities and what they are and how we solve them and how we work with them. So with the and type, I think it's helpful to think about it as kind of an intersection thing. So let's say we have one inequality that is, let's just go back to our example, x greater than 3. Okay, that is going to represent a set of numbers, okay? Like, with equations, usually we only have one solution to the equation. Well, with inequalities, we can have a lot of solutions, and so all the numbers that are greater than 3, we're just going to represent that with the big blue circle here, kind of like a circle. And so now we have this big blue circle of all the x that are greater than 3. Now, all the x, our second inequality, which is the x that are less than 5, that's going to make up a different circle, right? And that circle is going to be kind of like this, right? And so if we're using and, then, so if we say x is greater than 3 and x is less than 5, what we're talking about is really this stuff right in here, where they intersect, right? Where they're both true. So where those two circles intersect, that's where x is greater than 3 and x is less than 5. And so I'll show you what I mean also on a graph here. So if we wanted to graph something like this, we would start with the x greater than 3. So let me create my number line. We're going to need a few number lines today. That's ugly looking. Okay, so we have 0, 1, 2, 3, 4. I'm only gonna go that far. I guess I need to go 5. 5, -1, -2, -3, -4, -5. I'm just going to duplicate this real quick because I don't want to waste time drawing that 2 more times later on. Nope, that is not what I meant to select. Yikes. It doesn't know what I'm trying to do. Okay. All right. Let's duplicate that down here. And then I'm going to duplicate that again right down here. Okay, so now I have our 3 number lines. And what I'm going to do is I'm going to first graph x is greater than 3, right? So we start at 3, okay? And we're going to go out from 3, greater than 3. That's all this way. And then because it's not greater than or equal to, we're just going to use this right here, this curve. Actually, let me make this x less than 5 up here. Let's make that less than or equal to 5, just so we can kind of get all the different pieces going on here. Okay, so now let's graph x is less than or equal to 5, right? So that's going to be, we start at 5, and we go all the way this way, right? And then we're going to use that bracket because it's less than or equal to. And then finally, we're going to graph that last, the green section, which is x is greater than 3 and x is less than or equal to 5. So let's label these real quick. This blue is x is less, sorry, wait, did I say? No, greater than 3. X is greater than 3. This red one is x is less than or equal to 5. Now we're going to do the green one. And what's the green one going to be? The green one is going to be x is greater than 3 and x is less than or equal to 5. Okay, so what we're going to start by doing is let's do this in yellow, I guess. I'll draw both of these. So we're going to start with the 3 one, right? And we're going to graph that out over here, kind of like this. Use our curve. Then I'll also graph the 5 one, so that's going to go way out over here. And then we'll use the bracket. And then we're going to say, okay, where they overlap, that is where our graph of x is greater than 3 and x is less than or equal to 5 is going to be. So that is right here, starting at this curve here, and then going out and then hitting this bracket, okay? So you can see that this, which is x is greater than 3 and x is less than or equal to 5, this is really just where these two up here kind of overlap each other. So that is how AND works, and OR works a little bit differently. I'll get to that in a second. Now that we know how to do this, and if you remember our interval notation, we actually know how to write this. In interval notation, that's going to look like this. 3, 5, bracket over there, right? That is going to be how we graph it and how we use interval notation. Now we're going to say, okay, how do we solve that? So I'm going to give us an example, and it's very, very similar to how we solve linear inequalities when we just have one. So let's say we wanted to solve 6x minus 3 is less than 9, and 2x plus 9 is greater than or equal to 3. How would we solve that? So the way we would solve this is we would solve the first one, then we would solve the second one, and then we kind of consider those two answers together, right? So basically, we'll start with this left one here, right? 6x minus 3 is less than 9. We're going to add 3 to both sides, so 6x is less than 9 plus 3 is 12. Divide by 6 on both sides, so x is less than 12 over 6 is 2. So that is the solution to that one, right? And then we say and, right? And then we do this one over here. So we're going to add subtract 9 from both sides. So 2x is greater than or equal to 12 again, right? Because, not 12, negative 6, because 3 minus 9 is negative 6. And then we're going to divide by 2 on both sides. So we're going to get x is greater than or equal to negative 3, right? So now we have both of these answers, and it turns out that our answer to the whole thing is actually just this kind of all together, right? X is less than 2 and x is greater than or equal to 3. Okay, so it's pretty simple. It turns out there's another way we can write this, which is sometimes easier and quicker and used a lot. We call this the double inequality, and it's kind of this sort of form. A is less than x is less than b, right? Or is greater than equal, that kind of thing. And so in this situation, the way we'd write it is we know x is less than 2. It's also greater than or equal to negative 3, which means that negative 3 is actually less than or equal to x. And so we can write this up there the same right here, right? Those are both the same thing, but they are set up the same way. Or sorry, they're set up in different ways. And it actually turns out that if we have it written like that, we can actually solve it all at the same time. So if we have this example of negative 4 is less than or equal to 3x minus 7, which is less than 8, we can actually solve this all at once. This is two different inequalities, but we can solve it at the same time. And the way we do that, you'll notice we have kind of three sections here, right? With equations and inequalities before, we had two sections. Now we have three sections. With each of these three sections, it's kind of the same as with equations, right? Think of it kind of like a scale where you're balancing three different things at the same time, right? You want to keep it all balanced, so you just have to do the same thing to all three sections. So, let's just kind of go through an example, and that'll, I think, help solidify this. So I'll add 7 to all three sections. So negative 4 plus 7 is going to be 3, positive 3. That's going to be less than or equal to 3x, right? Because the plus 7 will cancel with the minus 7. That's going to be less than 8 plus 7 is 15. Okay? And so now we're going to divide by 3 in all three sections. So this 3 over 3 will become a 1, is less than or equal to x, which is less than 15 divided by 3 is 5. So that would be our answer to that. And so you can see sometimes that's nice because you can do it all in one go rather than starting with one and then the other. And it's just another way of doing it. So that's how we kind of solve the and types. Now, I want to make it clear with these double inequalities, this only happens with and, right? This doesn't work with or. So I just want to put that out there. This kind of notation here where we have less than or equal to is less than. All that only works with and, does not work with or. When we have or, that's kind of like this situation that we had up here before, except that instead of combining these, and taking out, right? In this situation, we basically got rid of everything over here and everything over here. Well, when it's or, we're just going to be keeping everything. So what that's going to look like, I'm not going to graph it out because that would take too much time. I'm just going to go kind of quickly through this. Let's say we had x is, greater than 3, right? Or x is less than or equal to 5. So we actually have a name for this. This is called the union of two sets. So what that means is we're kind of taking both of these sets, and sets, that's just sets of numbers represented by these inequalities, right? So it can multiple numbers, right? There's a lot of numbers that work with this inequality. So we're taking both of those sets of numbers and we're putting them together. It's a union, right? And so this particular union here is actually going to turn out to be all of the real numbers. And the reason is because x greater than 3, that's going to go off infinity to infinity to the right. And then x is less than or equal to 5 is going to go off to infinity, negative infinity to the left, right? So it's going to look like this. That would be, all the numbers that satisfy that inequality. Okay, so let's do an example of how we would solve these. It's pretty similar. So let's say we have 5 minus 3x is less than or equal to negative 1, or 8 plus 2x is less than or equal to 5. Oops, 5. Okay, and what we're going to do, it's the exact same thing as with the and, right? We're going to solve one, then solve the other, and then we're going to kind of put them back together with that or again. So in this one, I'm going to subtract 5 from both sides, so we'll get negative 3x is less than or equal to negative 6. We're going to divide by negative 3. Now this is going to be interesting. If we divide by negative 3, we get x. That symbol is going to switch, so it's going to be greater than or equal to, right? Because we're dividing by a negative number. That negative 6 divided by negative 3 is going to be positive 2. So x is going to be greater than or equal to 2. That's our first solution, right, on the left. Or, and then we do it over here. So subtract 8 from both sides, we'll get 2x is less than or equal to negative 3, I think. And then divide by 2 on both sides, x is less than or equal to negative 3 halves, right? So those would be our two different inequalities that we get now. And we just combine them back with that or. Okay. So now we've got those covered. I just want to quickly do like a word problem with these. So let's go down here. It's a long word problem. It says, due to the drought in California, many communities have tiered water rates. There are different water rates for conservation usage, normal usage, and excessive usage. The usage is measured in the number of 100 cubic feet, or HCF, the property owner uses. During the summer, a property owner will pay $24.72 plus $1.54 per HCF for normal usage. The bill for normal usage would be between or equal to $57.06 and $171.02. How many HCF can the owner use if he wants his usage to stay in the normal range? What does that mean? So we know that his usage is calculated in the number of HCF that he uses. So we're going to call that N. And then what we want to do is calculate what is his bill going to be based on that. So what we get from the problem is he's going to be paying $24.72 plus $1.54 per HCF. So what that means is we're going to have $1.54, or just 1.54 times N, the number of HCF, right? 154 per HCF, plus that sort of base number of $24.72. So that is what his bill is going to be. And what we want it to be between or equal to $57.06 and $171.02. So it'll be greater than or equal to $57.06 and less than or equal to $171.02. So just to make that clear, it says to go between or equal to, right? So that's what these less than or equal to, that's what those are for. And then we're just getting these numbers right here. This one's the smaller one, so it goes on the left, and then this one's the bigger one, so it goes on the right. How many HCF, so how big can N be, use if he wants his usage to stay in the normal range? So we'll just solve this compound inequality, right? So we're going to start by subtracting $24.72 from both sides. I'm going to use this calculator for that. So $57.06 minus $24.72. That's going to give us 32. Well, let's do that in black. $32.34 less than or equal to 154 N less than or equal to subtracting 24.72 from 171.02 is 146.3. Okay, and then now we're just going to divide all of these three sections by 1.54. So 32.34 over 1.54, 21 HCF is less than or equal to N, which is less than or equal to 146.3 divided by 1.54, which is 95. So this is the range that his HCF has to stay in, right? So what could, it says how many HCF can the owner use? Well, if we're assuming the maximum amount that he can use, it'll be this 95 right here, right? So this is how much that the owner can use. Sorry, let's circle that in red. N is going to have to be equal to less than or equal to 95. So for the max, right, if we wanted to get his maximum amount that he can get, then N would be equal to 95, right? That's the most water he can use while still being in that normal usage tier. And that's in HCF too. Yeah, your physics professor would kill you if you left that off. But So now, you've done, and inequalities, or inequalities, and now we've done a word problem here. I would just recommend practicing this more and more. It's pretty similar to what we did just with a single inequality. It's just kind of the next level. And then in the next video, I'm going to take it up to the next level after that, which is using absolute value. So I'll see you in that video. And yeah.